first three problems from today's weekly contest, I think 424. We again, in the first problem, we are given numbers array and we are asked to find basically to simulate a certain thing, which is nothing but if this is a problem 1 0 2 0 3, then the numbers that are not zeros can be considered like a wall, and these walls can be basically reduced if this particular point or particular ball strikes it. So we can start or we can choose numbers which are 0 as critical points, consider them as critical points. We can start from this particular 0 in left or the right direction, and we want to end up making all the particular balls to 0. So if we strike it, we decrement it by 1 and we change our direction. So we can start from here, go here, this becomes 1, this becomes 2, we go back, making it 0, this gets removed, we go back, make this 0 or 1, we come back, make this 0, we move this, we now change our direction since we have strike this, and we make this 0, removing this. So now all of the elements are 0. So that's what we want to do for every, and we want to find all the valid selections, right? So a selection is nothing but considering a critical point and either going left or right. So these are two different selections, and we want to find all such selections, right? So given the question and the constraints are very low, we can just simulate this. But there's a better approach, that is we can just start from every critical point and see, because at every critical point we are just worrying about the left half and the right half and how many walls are there. So what is the total power of walls from the left half and the right half? If they are equal, like in this case, then we can just consider this particular critical point and we can just go left or right. So two answers, right? But what if we have a scenario like this? 2, 3, 0, right? So there was 1, 0. Now I don't consider that. This is a critical point. I can go left or right from here, but if I go left, I won't be able to make it 0. This will be 1 and this will be 0, and that's the last state that I'm going to get, and I'm going to go out of boundaries and there's nothing, there's no coming back. So there is only one answer here, that is towards left, right? So for every critical point, since we are worrying about the left and the right half power, we can just have a prefix and suffix and use that for getting the answer. So, and if the prefix and suffix for a critical point are equal, then my answer gets incremented by 2. Otherwise, if they are having a absolute difference of less than equal to 1, then it gets incremented by 1, right? So that's how we are going to solve this problem. We can have a prefix vector and a suffix vector. Initial value of prefix will be 0. Similarly for suffix, it will be 0. We can iterate for every query, for every number and get the prefix and suffix. So since for the suffix part, I want to consider, or I'm interested in the opposite half, other end. So int j number size -1 minus I, and prefix will build over the last value, sorry, plus nums of I. Similarly, suffix will build using nums of j over its last value. Now that I have prefix and suffix, I can just have an answer. So for every critical point, I will iterate and I will get the other half as well, because for suffix, I want to consider the other half, right? Because I'll be having suffix in this order, but not really in this order. I require it in this order, but I will have it in this order, right? So just for clearing things out, for this particular number or array, I will have a prefix of 0, 1, 1, 3, 3, 6, and a suffix of 3, 3, 0, sorry, yeah, 0, 3, 3, 5, 5, 6, right? 3, 3, 5, 6, 6, 5, 6. So yeah, so this will be my prefix and suffix. So for this particular critical point, I will look at a, a prefix of this. So prefix will be of the left half, that is 3. So my prefix will be this, or actually this itself, right? So I plus 1, and my suffix will be the right half. The right half will be j equal to n minus 1 minus I, right? So this will be my right half. So let's get that. Int j is equal to nums dot size minus 1 minus I, and for every critical point, I will check if nums I is equal to 0. I will check if the absolute difference between the prefix and the suffix j plus 1 minus the prefix I plus 1, if it is less than equal to 1, then one valid selection will definitely be there in one of the direction. And on top of that, if suffix of I plus 1 and j plus 1 and prefix of I plus 1 are equal, then one more answer is there, because the other direction is also possible. Return answer. Let's see if this works out. Time and space will be linear, and yeah, let's see the second problem. Zero array transformation part 1. We are given a numbers array and queries, and we are asked to perform the queries on this numbers array, which is nothing but taking up the range. So it's basically lower and upper limit within the range, within the bounds, and using those values for every index from this particular point to this particular point and decrement it by 1. If it is already 0, then we don't do anything, so we don't make things negative. And if it is not 0, then we try to make it, decrement it by 1 until and unless we reach a 0 array. So if we perform all the queries and we are able to reach, or we are able to make numbers array 0, then we return true, otherwise we return false. So it's mentioned that we are allowed to choose a subset of values between the ranges, so which basically means we can use it to our advantage and avoid making things negative. because we are not able to increment it, only decrement it. So our motive is to make all the numbers 0. If we are able to do it, return true, otherwise return false. So there is a famous way to solve this problem, again using prefix. So firstly, if we are given something like this, 2, 5, 9, 4, 1, 0, 3, right? Suppose these are the values, these are the indexes, and we are asked to perform the query query 2 comma 5, right? So we need to increment it by 1 for all these values, right? So we can just take the extreme values, like at the point where the lower limit is. So that is, we can do a +1 here, and we can do a -1. Suppose we add a prefix, so we can just take the prefix, do a +1 here, till the upper limit plus 1th index. So this particular index, we can do a -1. So we can do the opposite what we did here in the lower limit. We end up getting a prefix of, now if we try to find the prefix, we'll get the intended array, that is this. So we wanted 2 to 5 to be incremented by 1, and we got that. And we can perform this for all the queries, and this will be a O of 1 operation, right? So doing the query will be a O of 1 operation, but finding the prefix will be O of n. So we can just do this efficiently using this method, and we can try to decrement it by using all the queries, and after that, looking at it, we'll able to see if we are able to get a value which is greater than the numbers value for that particular index. If we are able to do that, then we are able to achieve 0 for that particular index. And if we are able to do that for every index, then we return true, otherwise we return false. So let's define the prefix array. So let's have a size equal to nums.size. Let's have a prefix again of size and +1. Now for every query we are updating the prefix. So let's have a queries iteration prefix of which particular index, the lower limit, incremented, the upper limit +1, decremented, and this point we are good to iterate the prefix and calculate the prefix. By the way, right now it is not a prefix, it's just a query updated values. So now making it prefix will be incrementing it using the previous value. So this will be the prefix, and at this point, if prefix of I-1 is less than nums of I-1, that means we are not able to do it, right? So if we use all the prefix, all the possible queries that there is, and then even then we are not able to get a value that is greater than or equal to nums of I-1, then for this particular index, it's not possible. So we return true, we return false, and we return true otherwise. Again, linear space, linear time. Okay. Is equal to 1 minus 10 equals size, my bad. It's n. Let's submit it. Yeah. Third problem, zero array transformation part 2. Similar problem, just that we are having another value which represents, instead of now decrementing it by 1, we are at most we are able to use at most value I, that is the third index of queries, and we are asked to find the value of k which represents the first k queries as minimum as possible, such that we are able to make the array 0 array. Otherwise we return -1. So -1 in the case where we use all the queries and still not able to reach array 0, otherwise value of k. So basically we are doing the exact same thing, and if we look at the constraint, we see queries and nums are still for 5 in size. So we exactly follow the instructions of what we did in the first part. Then we are able to get it in terms of in O of n square time complexity, which is not possible with this constraint, right? Because what we will do is, for every query we are trying to find. So if we use the first query, we are able to we check, we build the prefix, try to see if we are able to make all the elements 0 or not. For the same thing we are doing, we are going to do the same thing for the second index, third index, fourth index, and so on and so forth until we are able to do it. Otherwise we return -1. So in worst case, that will be O of n square time complexity. If we try to uh, store the prefix of every index or every query that we see or that we do, that will lead to MLE, and that won't help us, even though that will be helpful in terms of building the prefix. So what can we do? Since we have a 10 to the power time complexity and we want to bring it down to O of n square or O of n log n, but O of n is not really possible. If it is possible, then we have to store values, which will lead to MLE because the constraints are high. And that's why we are going to, okay, yeah, that's why we are going to use binary search, because O of n log n is usually a binary search. So what we can do is get this range space or the search space, that will be the index from 0 to the query size, and that is going to be our answer k. So we can do the binary search on index, and for every index we are going to build the prefix and do the exact same thing. Now that we have a value of I, instead of decrementing it by 1, we are going to do it for this much value. So we are going to take the extreme value and see if we are able to get a value greater than the numbers I value for that particular index. If we are, then we are good. Otherwise, we try to go towards right. If we are able to do it for the particular index that we have intended to, then we go towards left, right? So our search space will be 0 to queries.size -1, and let's get n inside size for the prefix, for building the prefix, and that will be inside the binary search, right? So we'll get the middle value, we'll get for this middle value we are going to build the prefix. So this means this particular index that is in queries, so from 0 till middle, we are using the queries. We're using the queries on prefix, which is of n+1 size. So int I is equal to 0 till middle. We are going to update the prefix of I0. This is the lower limit. We are going to increment it by the second index of queries. And we are going to decrement it for the upper limit. Now that we have the prefix, we are going to iterate and make it a prefix. And for every making, we'll check if we are able to. Let's make the prefix first. Prefix of I plus equal to prefix of I minus 1. So now that we have this, so if prefix of I minus 1 is still less than nums of I minus 1, then in that case, I should break. But I should have a flag so that at this point I will know where I came from. Either I completed the loop or not. So let's have a flag, initial value 0. Let's make this flag 1, break it here. If flag is still 0, that means we are able to make all the values 0 if we choose 0 to middle number of frequencies. So our answer will become mid plus 1, and we'll go towards left so that we find a better answer. Else we go towards right. But there is a edge case. What is the edge case? Let's see this if this works. This will break on one edge case. Okay, this should be n. That edge case will be nums.size. Sorry. Okay, we don't have answer. Answer's initial value will be -1, because if we don't enter this position ever, then we return -1 here. It's not possible. Okay, for some reason things are not going right. Okay, fix queries, middle. Oh, my bad. So we are going to be careful and not make this mistake of implementing the wrong index. So queries of I of 1 plus 1 is the increment or the index that we need to decrement it. So let's see now. Okay, yeah. So this is the edge case that we'll miss, and that is because we are trying to perform on this particular index, and if this particular index is already 0, then we should not take this index, right? We should take the index that is 1 lesser than this. So we can have a particular flag which will tell us if the particular index is 0 or not. So initial value is 0 if nums of I minus 1 is it's not equal to 0, suppose. Then we make this flag true. So at this point, if we have this flag true, that means we are good to return mid plus 1 or have mid plus 1 in our answer, because the current index or the current value is not 0. So we have to do it, and we have to consider that as a query inside our query. So that will be a flag 2. So if flag 2 is still is 1, then it means that we are going to return or have mid plus 1. Otherwise, we are going to have mid. So that will be 1 less. Time and space will be, sorry, this flag 1. Time and space will be of n log n, and space will be of n. And these are the three problems. Thanks.